And moving on with parabolas, we're going to look at graphing y equals ax squared plus bx plus c using the axis of symmetry formula y equals minus b over 2a. Here we go. What we're doing now is we're graphing the full ax squared plus bx plus cx plus c equation for the equation of a quadratic function. So remember, this is a quadratic function. It's a polynomial, degree 2, leading coefficient a, and it's like I said, it's a trinomial. And what we're going to do is graph what happens when we've got an a and a b and a c value. Okay, what happens when the b value is not 0? So that's what we're going to be exploring today. And we're just going to jump into an example straight away. So we're going to graph this function here. So notice I've gone back to function notation. Right? Remember, you can simply change that to y equals negative 2x squared minus 8x minus 3. First thing we're going to do is find something called the axis of symmetry. So what is an axis of symmetry? Let me explain that first. Let's say we have a quadratic function, which of course is a parabola shape. The axis of symmetry is a line. It's kind of like the spine, okay? It's a mirror line straight down the middle. And when we draw the axis of symmetry, hopefully you've heard of the word symmetry before. It means sort of the same, like if you split something down the middle, it's like a mirror image or an axis of symmetry. Many different shapes can have an axis of symmetry. It's a line that goes straight down the middle of the parabola, but it's not actually part of the parabola itself. So we do it as a dotted line. So the function itself is the red one here, but the axis of symmetry is not part of the function. It's like a guideline that helps us graph it. Okay, so that's what an axis of symmetry is. And we're going to find it for this quadratic function, this parabola. So here we go. And what we do first is we identify what are A, B, and C for this question here. We've got A, B, C. My A is negative 2. Be careful here. A is not negative 2x squared. A is just negative 2. It's the number in front of the x squared. It's the number stuck to the x squared. B is negative 8. And C is negative 3. And straight away, the y-intercept is C, remember. Y-intercept is going to be 0, negative 3. The y-intercept is always the C value. And that's going to come in handy later. The axis of symmetry is this. The axis of symmetry has an equation. It's x equals negative b over 2a. That's the formula for the axis of symmetry. Note when I drew it before, the dotted line, it was a vertical line. Remember back in semester 1, vertical and horizontal lines, they have an equation x equals something or y equals something. When we have a vertical line, it's always x equals something. So the axis of symmetry is not a point, it's a line. And what we do is we put our numbers into that formula. So you've got to remember this formula. It's a little bit annoying, but you've got to remember it. X equals minus, b is negative 8, over 2a, which is negative 2. Be careful of all the minuses here. This could put you off. So what we have is x equals minus, minus, minus. We've got 3 minuses, all with positive and with division and multiplication involved. So we're going to end up with a negative. 3 negatives is going to end up with a negative. We've got 8 over 4, which is negative 2. So the axis of symmetry is x equals negative 2. The axis of symmetry is not negative 2. The axis of symmetry is the equation x equals negative 2. It's got to be an equation. So what we do now is show it. We're going to show this by graphing this vertical line, and we do it dotted. So here I go. Like so, and let's do our labeling. So I'm going to put arrows to signify that it keeps going up and it keeps going down. And let's put the equation next to it, x equals negative 2. So that is the axis of symmetry done. Okay, we've got the equation of it, and we showed it. Next thing is we're going to find the vertex. Now the vertex, I haven't explained what a vertex is yet, I believe. Yeah, I'll just draw this again. So there's some generic random parabola. And there's the axis of symmetry. There it is. I might abbreviate it to AOS. Save a bit of time. What a vertex is, it's the lowest point or the highest point on a parabola. This point is always on the axis of symmetry and where it touches the parabola. So that's the vertex here. All right, so you've got your axis of symmetry, and the vertex is always on the axis of symmetry and on the parabola at the same time. So it's always like the lowest point or the highest point. And the vertex is a point. So you've got to be very careful. The axis of symmetry is a line. The vertex is a point, so it's got to have coordinates. So how do we find the axis of symmetry for a parabola? Very easy, just a little algebra. We take our x value from the axis of symmetry, x equals -2, and we put it back into the original equation. Okay, so we're going to put y equals -2 times x squared, -2 squared, minus 8 times -2 minus 3. So can you see that I've just replaced x up here with x equals -2. And I might use function notation. I might stick with this. So this is going to be f of -2. Does that make sense? Now let's go through and just use our order of operations, our PEMDAS or our BEDMAS, and evaluate this. -2 times -2 squared is plus 4. The negative is getting squared as well. Minus times minus, plus 16, minus 3. Take the steps here. Don't do this all in one step because you'll probably get it wrong. Minus 8 plus 16 is 8, minus 3, which is 5, and we get that value there of 5. Now, that is not the vertex. What is the vertex? Remember I said the vertex is a point. The vertex is the point -2. Okay, the x value for the vertex comes from the axis of symmetry. And the y value for the vertex comes from what you just found there, 5. So that is the vertex. It's the point -2, 5 for this question. And now let's show it on the diagram. So it should be on the axis of symmetry. Let's check it out. -2, 5, -2, 5. There it is. So there's our vertex. Let's label that vertex -2, 5. Okay, the more detail you can show, the better. Okay, so that is the axis of symmetry and the vertex. See now, it says find the y-intercept and show. Well, we actually did that already. All right, when we looked up here, we got c equals -3. So straight away, the y-intercept is just 0, -3. Remember, the y-intercept is always going to be the point 0, c. Okay, because we identified c straight away. So 0, -3, where's that? That is going to be right here. There's our y-intercept. Looking good. I'm not going to write the coordinates next to it because I'm right on -3 there. It's pretty obvious. D, we're going to graph the parabola using all the information that we have so far. So what we can do here is, remember, this is the axis of symmetry. It's like a mirror line. Okay, so if I'm here on the parabola at -2, -3, I go 1, 2, and I've got a point. I can also find another point on the other side. I just count 2 from here and go to the other side. 1, 2, and I've actually got another point over here. And what are the coordinates of that? -4, -3. So whenever you find a point on one side of the parabola, you can use your axis of symmetry to automatically find another point on the other side. So this was just 1, 2, and then 1, 2, and I've got another point. So I now have 3 points. And I'm going to use these 3 points to graph the parabola now. So remember, no sharp edges. And down the bottom, it should go all the way. We call this a viewing window, okay? We call this sort of rectangle here. Can you see it? This is whole rectangle where the arrows are for my x and y axis. We call that a viewing window. When we draw our parabola, make sure it doesn't stop here. It's going to go all the way down to the bottom. And by the way, is this going to open up or down? Our a value is -2, which means we have a negative a value. And whenever we have a negative a value, that means it opens down. So hopefully you can see that it will open down. Now, I'm not good on the board with this, but I'll do my best. And there it is, our opening down parabola. So what I might do now is write the equation next to it. So this is the function f of x equals -2x squared minus 8x minus 3. And there we go, we have graphed it. That is D done. Next thing, another question it might ask is, does this function have a maximum value or a minimum value? Every parabola will have either a maximum value or a minimum value. Let's have a look. Does it have a minimum value? No, it just keeps going down and down and down forever. It has no minimum. Does it keep going up forever? No, it doesn't. It has what we call a maximum value, okay? So if a parabola opens up, then it has a minimum value, which happens there. If it opens down, then what we say, it has a maximum value. It's going to have a maximum value. So make sure you understand which is which. If it goes down forever, it doesn't have a minimum, it has a maximum. If it goes up forever, it doesn't have a maximum, it has a minimum. So here we're going to have a maximum value. Let's just say max value. And what is the maximum value or the minimum value? The maximum or minimum value is always the y-coordinate of the vertex. So it's like the largest or the smallest possible y value it has. So our maximum value is always the y value of the vertex. So here we're going to have a maximum value of 5. Okay, that's it. That's all you say. Remember, it's always the y value. So how high does it go? The highest this goes is 5. Okay, that's the maximum value. And just to finish off, if we wanted to find another point on this, just to make sure what we've done is correct, I've just picked a random one here for the question. Put x equals -3 for another point and show it. So let's just find another point here. X equals -3. What we're going to do is find another point on the parabola that has an x value of -3. And we're just going to go ahead and how do we get the y value for it? Well, we go back up into the equation. So we're going to find, we replace x with -3. So we're going to find f of -3. We put that in 2, -2 times the -3 all squared, minus 8 times -3, minus 3. -3 squared is +9, minus gives +3, it's a 24, minus 3. Do the steps here, everyone. Don't skip steps. Minus 18, plus 24, minus 3. Nearly there. Minus 18 plus 24 is 6, minus 3 is 3. And that gives us our second point. So we take this and we put it into this point here. This gives us another point, -3, 3. Does it work? This should appear on our parabola. So let's plot this point and hopefully it fits right on the parabola just nicely. Nice and cozy. So where is it? -3, 3. Ah, there it is. Okay, so to show that, let's just put a dot on the parabola and write the coordinates of the point next to it. And there we go.